Hey guys, Dr. Pitcher coming in with another fantastic chemistry video, and today we're doing solutions and electrolytes. What's a solution? Well, a solution is a homogeneous mixture of a solute and a solvent. What's an electrolyte? An electrolyte is a charged particle, sodium, chloride, whatever, dissolved in water. Two types of electrolytes, strong and weak. A strong electrolyte dissociates completely in water to give you the cation and the anion. There is no parent molecule at that point. A weak electrolyte, however, dissociates only slightly in water to give you some cation and some anion, but there's lots of that parent molecule still kicking around in the solution, dissolved up in the water. All right, guys? So we're going to do some experiments today with electricity. We're going to see which kind of solutions will conduct electricities and which ones won't. Strong electrolytes will, big hint. Weak electrolytes will too, but only slightly. And non-electrolytes will not conduct electricity at all. All right, guys, let's get after it. Let's get into it. Let's get it done. All right, guys, now we're going to start by doing this electricity experiment. What we're going to do is we're going to take one of these beakers that are filled with a solution. Some of them are strong, some of them are weak, some of them are just not electrolytes at all. And we're going to put them between these two electrodes. Now, I can assure you this is plugged in, but the circuit is broken right here. So the only thing that's going to connect this wire to this wire is the solution that we put under it. Okay? So let's start off with everybody's favorite, water. Water, as you can see, by itself, doesn't conduct electricity, at least in this experiment, at all. Now, it will, if you put enough energy through water, it will conduct electricity, but it takes a lot. All right, guys, so that one is a non-electrolyte. Water is a non-electrolyte. Next, 1 molar sodium chloride. Let's see what happens. Oh, look at that. Bright, bright light. Sodium chloride dissolved in water definitely conducts electricity. It is most definitely an electrolyte. Let me get a little shot of water to clean off my poles. There we go. Next, 1 molar hydrochloric acid. Let's see. Oh boy, look at that. That light is brilliant bright. Hopefully you can see that on the camera. HCl, hydrochloric acid, is definitely a strong electrolyte. Isn't that cool? All right, let me just give my electrodes a quick rinse. There we go. And finally, acetic acid, the flavorful ingredient in white vinegar. Boom. Now, I don't know if you can see this on the camera. That light is definitely coming on. Let me turn this light off here, see if it helps. See if you can see it. That light is definitely coming on, but it comes on very, very faintly. In the video, I hope it's coming out in the video, guys, this light is just barely glowing. Okay? So this is indeed an electrolyte, but it's a weak electrolyte because it doesn't conduct electricity very well. Okay? So that's the end of the instructor demo of this portion of the lab. Now let's move on to the student part of the lab. All right, guys? See you then. Okay, guys. We have a series of household products or food products that we want to test in our electrolyte experiment. So what we're going to do is we're going to take jars like this. This one contains fruit punch. And we're going to put it under the electrodes. And we're going to see if it lights the lamp. Now, the ingredients here are high fructose corn syrup, juice concentrate, and citric acid, vitamin E, and some natural flavors. Not a lot going on in there in terms of electrolytes. Citric acid is a weak electrolyte, but as you can see, the light doesn't come on, and that's more than likely because the concentration of citric acid, which is a weak electrolyte, is so low that it doesn't register on our test. Now, that's something that you need to think about for a minute. Concentration does matter. I mean, even though it's an electrolyte, the concentration is so low that there's not enough ions to make electricity conduct. But citric acid is still a weak electrolyte. But you're going to put down negative for this. It doesn't light the lamp, non-electrolyte, because, quite frankly, it didn't light the lamp. Distilled water we've done before, so I'll just use it as a quick rinse. This is just distilled water. I'm just rinsing off the electrodes real quick. Nothing to write down there. All right, here's Pedialyte. Let's see if Pedialyte will light this lamp. And you may not be able to see it on the video. Let me turn the light off here. I guess you can see it. It lights that lamp very mildly, very, very subtle. And that's because Pedialyte has potassium citrate, which is a strong electrolyte. It also has sodium citrate, which is also a strong electrolyte. So that lit the lamp very, very mildly. The reason why it was so dim is, again, just concentration. There wasn't very much in there. Here, let me give it a quick rinse with the water here. There we go. Try again. Okay, here we go. Here we have sodium chloride, saline solution. There you go. You can see the lamp lit up pretty good because we've already determined that sodium chloride is a strong electrolyte. And again, saline solution is sodium chloride. It's a certain percentage of sodium chloride, about 0.9%. It's known as saline solution. Here's ammonium hydroxide. Ammonium hydroxide. And you probably can't see this on the video at all. Let me see if I can help out here. You might be able to see it. It does indeed light that lamp. Ammonium hydroxide is definitely an electrolyte, a strong electrolyte at that. But again, it's this concentration. And finally, last but not least, Publix Club Soda. And as you can see, not a lot happens with that because this is a non-electrolyte. All right, guys? And that is the end of part 2. So I'll see you guys in a minute for part 3. Okay, guys, we're going to start with part 2. I think it's 2 of this experiment, the solution concentration. We need to weigh out some stuff here and get it done. So we're going to make a small change from the book. The book says to use vitamin C, and I'm going to use the sodium salt of vitamin C because it just dissolves better. And there's the molar mass. You might want to write that down. 198.11 grams per mole. You're going to need that in the calculation, so write that number down. 198.11 grams per mole. Grams per mole. I'm going to write that unit down too, right? Very nice. All right. So we're going to weigh out about 0.15 grams. Or 150 milligrams. So here I go. Again, it doesn't have to be, well, you do want to try to get this one as accurate as possible because we are going to be comparing it to a standard. So I'm going to try my best to get 0.15. Really close, gotta be careful. That's real close. A little bit more. Oh, come on. .153. I'm going to take it. It's a little higher than I want it, but I'm going to take it. So 0.153 grams is how much we're going to put into the volumetric flask. All right, so we'll see you then. Okay, guys, now we're going to learn how to use a volumetric flask. This is what we have in my hands right here. This is a 50.00 milliliter volumetric flask. What we're going to do is put the vitamin C in here using a little bit of water, and then we're going to top it up to this blue line right here. Now, I'm not sure you can see it. See if it'll get it to work here. There you go. There's the blue line. We've got to bring the meniscus to that line, and that's 50.00 milliliters, okay? So that's what we're going to do right now. Let me grab a water bottle. It's over here. I'll be right back, guys. Sorry. Okay. Now, I'm going to take my vitamin C that I have right here. We previously weighed this out. And I'm going to carefully, ever so carefully, transfer it to here. And with a little shot of water, just a little bit now. You don't need too much. I'm going to rinse out the weighing dish. So I got a little bit of water in here. I'm going to swirl it around. I'm going to pour that in there. because it's important to get every molecule of vitamin C I weighed out into the volumetric flask. Here we go. And there we go. So that's 2 rinses, that's enough. So now with the water bottle, I'm going to bring the volume up to 50.00. Now as you get closer to that line, you want to stop using this crude little squirt bottle and you want to start using maybe a pipette. So I'm just about there. There we go. I'm going to start using a pipette because I don't want to have to refilm this video, to be honest with you. So here I am over here. And I don't know if you can see this or not. Let's see if we can get it on camera for you. There's the... So then I'm just going to drop water. To get that meniscus right on that line if I can. I need a little more water, just a touch more. Just a drop might be enough here. I don't know if you can see it or not, guys. I'm doing my best for you. I'm going to call that on the line. Looks good to me. All right, so there we go. Now, we put the cap on it. And now we have to shake this thing to get good homogeneous mixing. So you invert it, you shake it, you revert it, you invert it, you shake it, you revert it, you invert it, you shake it. You do this 10 times, guys. You do this 10 times. And I'm sure by the 5th time you'll wonder why you're doing it. And it's all about getting homogeneity in the solution. That's what it's all about. Homogeneity. Okay? That's about 6 times. We'll do this 4 more just to make sure we get good mixing of our vitamin C in our solution. Now what we're going to do is we're going to compare this solution to a standard solution of known concentration. So there's another solution that's been made. That is my standard. That's my premium. That's the one that I know is made perfectly correct. And we're going to compare it to the one we just made together. And hopefully we did a good job and we get the same concentration in both. If not, we'll just calculate a percent error and, learn something about science. That it's not always easy to hit a target. But with practice and skill, we all get better at it. Okay, so this one is ready to measure. Now the next thing we're going to do is use, my head's off thing. There we go. The next thing we're going to do is we're going to use a spectrophotometer. We're going to measure the absorbance of this solution and the absorbance of another solution. Now when I talk about absorbance, I mean light absorbance. Vitamin C will absorb light, and we can measure its concentration by the amount of absorbance it can do. Well, I'll explain more in a minute when I show you the instrument. Okay, guys? See you then. Okay, class, here we are looking at a spectrophotometer. What we have over here is a light source that's going to shine light through this chamber right here. And there's a light detector on this side of the instrument. What's going to happen is as the light passes through our sample, the vitamin C that's dissolved in the water will absorb some of that light, so less light will get through to here than the machine sent out. So the machine sends out a known amount of light from here to here and can detect that. If anything's in the way in here that blocks the light from going from here to here, the machine will pick that up and it'll give us a readout up here. Okay? So the first thing we want to do is we want to use whatever solvent we use. Now this is called a cuvette. This thing right here is known as a cuvette. These are designed for spectrophotometer use. So what I'm going to do is I'm going to put some distilled water in there. This is the solvent we used. And I'm just going to measure I'm not going to measure the absorbance. The computer inside this machine is going to take the absorbance of this water and it's going to zero it. In other words, we're going to make sure that whatever absorbance we're reading is the absorbance of our vitamin C and not the solvent that we're using, because we don't really care about the solvent. So I'm going to hit re-zero right here. So then the machine is zeroing itself so that water won't give any readings. And as you can see, it's 0.000 because the solvent has been zeroed out. The machine is not going to register the amount of water. Okay? So there's my blank. Now here is a cuvette that I've already loaded with the standard. The standard vitamin C solution is already in here. So this is the gold standard, if you will. And you're going to write this number down in your book, and you're going to write it under absorbance of standard, right above percent error. Absorbance of standard. So here we go. And there's my absorbance of standard. So write down, by absorbance of standard, write down 0.480. And if you want to put a unit, put the unit A for absorbance. That is the absorbance of the vitamin C in the standard concentration. So now, my solution, the one that we made together, is right here. Hopefully, let me give it a quick shake, just make sure it's all homogeneous. Hopefully, it will give us at least a similar, if not the same, result. Let's find out. So here we go. Got my cuvette right here. I'm going to pour some into here. Oops, I spilled a little bit on the floor there. Luckily, it's just vitamin C. I guess probably a lot of you are taking vitamin C right now. Get rid of this. This is the standard. Put our sample in. So this is our sample going in. Hit the go button to do a measurement. Oh, didn't do as well. 0.400 is our absorbance. So we're off by a little bit. That's okay. Write that down in the absorbance of solution. The absorbance of solution on page 93 in the little table there for part 2. Now, I didn't tell you to write anything else down. Remember, these videos are for you to be the learned scientist, and I'm the pair of hands. You guys have to write everything down that you're supposed to write down as if you were here. And you have to do all the calculations as if you were here. You've got to learn this stuff, guys. You can do it. We all can work together and make this the most successful time in America's history, because we're going to work together, guys. Let's get it done, all right? All right, so that's the end of this lab, and I'll see you hopefully very soon. Stay safe out there, guys. Stay healthy, and good luck, good chemistry. Bye, guys.